Turn around in deep space, and Earth isn't just far away, it's gone. Not destroyed, not hidden, just impossible to find with your own eyes. Because from far enough out, our entire planet shrinks into the same anonymous pinpoint as 100 billion other stars around it. We assume that no matter how far a ship travels, it could always just turn back around. Point yourself toward home, fire the engines, and go. But the deeper you get into real deep space, that idea quietly falls apart. There's no compass out there, no fixed stars to trust. Even the sky itself is slowly rewriting its own map while you fly through it. By the end of this, you'll understand why some of the smartest engineers alive still call deep space navigation one of the hardest problems humanity has never fully solved. Here on Earth, navigation feels almost unfair. It's so easy. The North Star sits reliably overhead. Landmarks stay put. Maps stay accurate for decades. Now, leave the solar system. The moment you do, every one of those comforts disappears. There's no north in deep space, because north is something Earth invented for itself. There's no up, no down, and worse, none of the stars you navigate by are actually staying still. According to astronomers, the entire galaxy is rotating, and every star inside it, including our sun, is drifting through space at roughly 700,000 kilometers per hour. That means the exact star pattern you memorized on your way out simply won't exist anymore by the time you try to use it to find your way back.
So if the sky itself won't hold still for you, what does a spacecraft actually navigate by? This is where it gets genuinely strange. Every photon of starlight reaching your ship left its source years, centuries, sometimes millennia ago. You're not looking at where a star is, you're looking at where it used to be. For nearby travel, that barely matters. But stretch the distance out, and the gap between where a star appears to be and where it actually is grows wide enough to throw off any navigation system trying to use starlight as a fixed reference. NASA has actually tested a serious answer to this. In 2017, a NASA mission called Sextant demonstrated real spacecraft navigation using pulsars, dead, spinning stars that blast out radiation with the precision of an atomic clock. Unlike ordinary starlight, a pulsar's rhythm doesn't lie about timing, and researchers showed a spacecraft could calculate its own position by listening to those cosmic heartbeats. It's a genuinely elegant fix, but even pulsar navigation has a brutal limitation baked into it. Here's the part that breaks the whole idea of just turning around. Space itself isn't standing still. On the largest scales, distant galaxies are drifting apart as the universe expands. And even locally, gravity from every star, gas cloud, and dark matter clump you pass tugs your trajectory in ways that compound over time. Miss your intended path by a fraction of a degree at the start of a multi-year journey, and by the time you try to reverse it, you're no longer aiming at anything close to where you began.
Physicists call this sensitivity to tiny errors chaos, and deep space is full of it. Scientists studying long-duration trajectories have found that even minuscule miscalculations, smaller than a rounding error, can snowball into positional gaps of millions of kilometers over the course of a real interstellar-scaled journey. And there's one more twist waiting underneath all of it. Special relativity, confirmed repeatedly by physicists over the past century, means that time itself moves differently for a ship traveling at extreme speed compared to Earth. Years could pass back home while a crew experiences something shorter, so even if you retraced your exact path perfectly, Earth wouldn't be the Earth you left. It would have kept moving, kept aging, kept changing without you. Turning around was never just a matter of steering. It was always a question of steering back toward a version of home that, by the time you'd arrive, would no longer exist. So the next time you watch a movie where a lost ship simply reverses course and flies home,
Remember what that scene is quietly skipping over. No fixed stars, light that lies about the present, chaos compounding your errors, and time itself refusing to wait for you. If this rewired how you think about going home, you're going to want to see what actually happens to a human body during a real interstellar-length journey. That video goes even further down this same rabbit hole. What do you think would be the hardest part of finding your way back? Drop your answer below.